All right, have you ever heard the expression that if all you have is a hammer, everything looks like a nail? Okay, so you're just learning all of these tools for integration, and so you learn a new tool, you get a new tool to use, and everything looks like a nail. So, but let's take a look at this example. All right, so what I'm seeing is, I'm seeing this 1 minus z inside a square function, right? So it would make sense that we should let um, if you're going to do a substitution, we should let w equal 1 minus z. Okay? And then dw, though, dw would be, the derivative of 1 is just 1, and derivative of negative z is negative 1. So we end up with dw is equal to negative z, or negative dc, sorry, dz, which would mean that, well, dz would be negative, or negative dw would be dz. But we don't really have if I make that substitution, I don't really, I can replace this 1 minus z with w squared. I could replace the dz with a negative 1 times dw, but I still have this z to the fourth, and I don't really have a good way of replacing that with something in terms of w. And I can't take the derivative if I've got two different variables here. So this is not going to work. This is not going to work. Substitution is not going to help in this case. But don't forget the other tools that you have in your tool belt. All right? And one of those is just to rewrite this thing algebraically. All right? So I'm actually going to erase this so I can make a little room, because I'm going to need some room here. Because I can rewrite this algebraically. I can square this thing out, right? I got z to the fourth, and then I know that the square of 1 minus z is, now be careful, okay? Remember, you get a middle term, right? So you get 1 minus 2z plus z squared when you square that thing out, okay? You can always think of it as 1 minus z times 1 minus z, and then FOIL it, right? So you're going to get 1 times 1, and then you get minus z times 1, and then outer is minus z times 1, and then you get minus z times minus z, which becomes plus z squared, right? So you can always FOIL it out. Don't get yourself confused. Remember your algebra, okay? All right, and then I can distribute the z to the fourth through this through the parentheses here. So I get z to the fourth minus 2z to the fifth plus z to the sixth. Okay, so I'm just using algebra to rewrite it. So I would call this a technique of algebraic rewrite. Okay. All right. Now, everything's just a power function. I can just basically find the antiderivative of each term, right? Because I know that if I have a sum and difference, I'm taking the antiderivative, and finding the antiderivative of a sum or difference. It's just a sum or difference of the antiderivative. So I'll just find the antiderivative of each term. All right, so the antiderivative of z to the fourth is z to the fifth over 5. The antiderivative, I got negative 2, and then the antiderivative of z to the fifth is z to the sixth over 6. And then the antiderivative of z to the sixth is z to the seventh over 7. And then plus z. Okay, now I can clean that up a little bit. The only thing I'm seeing is I have a 2 over 6, which becomes 1/3. So I could also rewrite this as 1/5 z to the fifth minus 1/3 z to the sixth plus 1/7 z to the seventh plus z. Okay, so that's my answer. All right, moral of that story is just, substitution doesn't work for everything, and don't forget that you can also, there's other ways to approach the problem. One of them is to rewrite the integrand algebraically. All right, got one more example to cover, and then you'll be ready to work on the discussion questions.